Good day. This is Ashley Brinson, the Executive Director at the Warren Center. This webinar is going to cover some information that the Warren Center presented at the Ethics in Data Science Conference in late March. We organized a workshop on the Friday afternoon of the conference on health, genomics, and patient privacy. That workshop was in parallel with three other workshops associated with the conference. There was a data science and criminal justice session, a workshop session hosted by the Australian Human Rights Commissioner Ed Santow, and a session on data science and business-to-consumer commercial transactions following the Hain Royal Commission on Banking. This particular session was moderated by Ben Gilbert, the corporate attorney at legal affairs at Microsoft, and expert panelists included Dr. Sandra Johnson, pediatric clinician and president of the Australasian College of Medicine, Warren Kaplan, the Chief of Informatics at Garvan Institute, a leading genomics research institution in Sydney, and Stephen Bollinger, the Chief Privacy Officer of Cochlear Limited, a Sydney-based global market leader in implanted hearing technologies. The first part of the workshop was conducted under Chatham House rules of source confidentiality, and this brief presentation set the scene. Moore's law says that transistors are getting packed onto computer chips at an accelerating exponential rate. This yields computing that's cheaper, memory that's cheaper, ubiquitous sensors embedded in everything, and cheap cloud storage. We report the result of this in successive editions of the prototype. This story from March 2019 explains how personal electrocardiograms and third-party watch bands for smartwatches like the Apple Watch or Samsung Watch. These are being used as personal electrocardiograms now. If you look on Alibaba now, individual heartbeat sensors can be purchased for about $1 from China. This has led to just the explosion of sensors connected to worn technologies, wearable technologies. Frequently at the Warren Center, we talk about the ideas in Everett Rogers' innovation theory and about how the innovators and early adopters invent new technologies and then disperse those into the market. Gartner has a model about how technologies ramp up in hype, and sometimes they reach the peak of inflated expectations, the bulge in the middle of that diagram on slide 5. Wearable technologies seem to be on the rise, getting close to this peak. We try to tell the true stories and not be part of the hype, but this is an interesting time in health technology as we see so much data being sensed, being stored with machine learning applied to that stored data, and then with artificial intelligence on top of that. Slide 7. An example connected to genomics is shown in the next slide. There on the left, there's a gentleman looking at a printed human genome. It is said that if you stacked up all the papers, you would have about 1 cubic meter of paper just with the letters GATC written out again and again. This is the modern representation of the human genome, reading every piece of the human DNA. On the right-hand side of that diagram, there's a paper there from the Proceedings of the National Academy of Sciences. The last author is J. Craig Ventnor, one of the early researchers into the Human Genome Project. The faces at the bottom of the diagram show the computer-generated images of people's faces based on reading their genome and predicting what they might look like. Each of the pairs of faces, the image on the left is a photograph, the image on the right is the computer-generated representation of predicting what that person might look like. So the power of genomics is so strong that some of the researchers in that early Human Genome Project say that they might take a drop of the blood of a pregnant woman when she's in her first trimester of pregnancy and hand her a photograph predicting what her baby might look like on the baby's 18th birthday. The power of this technology appears to be very strong, and there's quite a bit of hope about how it might be used to alleviate health problems and increase well-being for people. 23andMe is the commercial consumer version of this now. So for US $99, just about any person can buy a kit, put a swab on the inside of their mouth, send that off, and have their genome sequenced. This isn't the full human genome, but it gives enough data that some predictions can be made. 23andMe has recently received approval from the U.S. Food and Drug Administration to make some predictions about a person's propensity to develop type 2 diabetes. This is the diabetes that comes later in life. And that's an example of the power of human genome data. We also see this technology being applied in other commercial non-medical applications such as Ancestry.com for that same sort of price point of around $100, $200. Data can be analyzed, uploaded to a website, and it's possible for subscribers to Ancestry.com and users of their kit to discover family members that they didn't know existed. One unexpected consequence of this data is that a cold case murder in California, the so-called Golden State Killer, his DNA had been left at crime sites, but police in California were not able to locate his, identify his, confirm his identity until distant cousins in his family had uploaded their DNA into a private company DNA database for genealogy, and police were able to match his DNA with DNA in a public database. So there's very far-reaching, unintended, unexpected consequences from lots of genome data out in the public. In fact, it's said that with just a very small fraction of the population, it would be possible to cover a large fraction of the population's genomics in a public database. In addition to genomics data, with the explosion of smartphone technology and ubiquitous apps, users are uploading voluntarily medical and health-related data into their smartphones. And it is not expected frequently by the user, but this data is frequently passed on to other apps, especially Facebook, especially some of the Google technologies, and users in this study that appeared in the BMJ journal in March 2019. It was a high fraction of apps were transmitting data from users, and a very low fraction of the users that actually understood that their data was moving in places that they didn't understand. One example of this locally is the integration of Apple technology with the hearing implant of Cochlear Limited. One of the speakers today and the experts is Stephen Bollinger. But you can see this tweet there from Tim Cook that was a proud acknowledgement that Apple was connecting to people with hearing loss and helping them hear their telephone calls and hear their music straight into the electrode of the cochlear implant. Quite a remarkable example of the power of technology. Another example of a medical device company here in Sydney where the data acquisition and sharing didn't go so well is ResMed. In a story that broke in November 2018, the case was described where sleep apnea device users, their data was being transmitted without their knowledge, and some people were unhappy about that. There's a sort of a pump that supplies air to a mask. And the user describes, this gentleman, Tony Schmidt, described in an interview that without his knowledge, he felt that the medical device was spying on him and sending data to his doctor, to the manufacturer of the device, to the local company that supplied it to him on a rental basis, and then transmitted that data also to his health insurer. He described that he was shocked and had no idea that they were sending information across the wire. That's sort of the darker side of the technology, or the unhappy side of some of the users who claim that they didn't know where their data was going. Data that is transmitted via apps can be quite sensitive and personal. It has become popular in the last couple of years for women who are planning a pregnancy to be inputting data about their menstrual cycle and fertility. And this data has shown up in Facebook. So it's been transmitted from one app in the smartphone into a separate app in the smartphone. And the purpose of this is to trigger to consumer products advertisers, people who are companies who are selling baby diapers, who are selling a baby stroller, who are selling baby food and baby formula, that a new consumer has come into the market, a new mother, a new father who would be purchasing baby items, very lucrative market. And frequently the users of the original app don't understand where their data is going. Governments are also collecting personal health data. This is an example, a screenshot from the MyGov, myhealthrecord.com website, and this is my personal data. So if you haven't, if you're living here in Australia and you haven't checked this out, or you haven't opted out of it, this is what the system looks like. There's a long terms of use. Won't go into that now. You'll need a lawyer to read through that, but there you go. Terms of use. You can create a password. I was surprised that the Apple standard password that came out with a very strong password wasn't accepted. If you have an Apple device, you can't put a hyphen in that password, but I got a password in. And then there is my health record. There's my secret name, Jonathan Brinson, Jonathan Ashley Brinson I am. But there's my record, what it looks like. And I knew that I had some prescriptions recently, so I tried to look for those prescriptions, did a search there, and then couldn't find any prescription records, but there were 48 documents in the health record. Eventually I found those, and there you can see 2 prescriptions from late last year when I went to the dentist, and the dentist gave me some an antibiotic and some painkiller for a root canal. So there's my opioid prescription given on the PBS. This raises an issue about the commercial incentives of prescription suppliers and the overall pharmaceuticals industry. As many know and have followed the story, Purdue Pharmaceutical in the United States has been accused and has recently settled lawsuits with the state of Oklahoma for hundreds of millions of dollars related to the supply of OxyContin and what is termed the opioid crisis in the United States. This is rising in news in America, at least, about how OxyContin, the illicit use of heroin, and then the abuse of fentanyl have cost the lives of potentially 400,000 Americans over the last decade or two. So there's quite a bit of animosity or suspicion in the public about the role of commercial enterprises in pharmaceuticals, and this is just a tip of the iceberg. It was documented last year, July 2018, that Sing Health, who had rolled out a similar sort of system to myhealthrecord.com here in Australia, Sing Health suffered a cyber attack, and the databases with maybe 1.5 million patients of data, including the prescriptions of Singaporean Prime Minister Lee Hsien Loong and a few other ministers. That data was compromised and passed on to hackers. These issues were among several issues that were discussed, especially genomics and medical devices. The conference was well received, and we expect a follow-up ethics and data science conference to be scheduled in 2020. Keep reading the prototype. We'll give you more information on this important topic of health, genomics, and patient privacy, and hope you enjoyed this webinar. Thank you.